Now we're looking at factoring expressions of the form of x squared plus bx plus c. Now before we go more in depth with factoring, I just want to review what the meaning of factoring is, or what exactly we're doing, right? So we all recall this when we get a product of two binomials, such as this, 2x plus 1 times x minus 3, right? We remember that eventually we multiply these two, we use the distributive law, we end up with that, and then we collect the like terms. That's our final expression, right? This over here is obviously a quadratic expression, right? So essentially what we've done here is expanding, right? Well, in factoring, it is as though we go backwards. We start from the result, we go back to the question, right? So that would be called factoring. So factoring is the opposite of expansion, right? So at this point, we've been seeing many quadratic expressions, right? Such as these ones. We've seen many quadratic expressions, right? Of different forms, right? And these are called, we've been using this name, right? These are called quadratic expressions, right? Quadratic expressions, or you may hear them as quadratic equations, quadratic relations. Essentially, they're all the same. It's just it depends on what context we are referring to them, right? But quadratic, that's the name of these expressions. And quadratic expressions, at least for this unit, we're going to use the term expressions. For quadratic expressions have a degree of 2. That means that the highest exponent is 2, right? And we can see that in all of these. Now you may know this already, right? But quadratic expressions, when we graph them, they produce a graph that is known as a parabola. And parabolas normally have a U shape, right? They look roughly like these over here, right? So this is our y-axis, our x-axis, so they may look like that, or they may look like upside down parabolas. These are rough sketches, by the way. Or they may look like these over here, where they just touch the x-axis at one point, right? And they sometimes may not even touch the x-axis, like these over here, right? And these over here at the top, the ones that we saw first, of course, are, you know, crossing the x-axis at 2 points, for example, right? So you see here it crosses the x-axis at that point and at that point, and over here at this point and at this point, right? So something to keep in mind whenever we're factoring expressions is that factoring is the process that allows us to find out the x-intercepts of each of these, right? So since the quadratic expressions that we saw before represent a parabola, a parabolic function, a quadratic function, a quadratic graph, when we find when we factor those expressions, we are essentially using a process that allows us to find the x-intercepts, right? Or where the parabola intersects the x-axis, right? Could be that way or that way. Even in this case over here, where it intersects the x-axis at one point, right? This one at also another point. And then of course we'll see that sometimes we won't get a solution for some of those quadratic expressions. That's because the parabola will not intersect the x-axis, right? So that is something to keep in mind whenever we are factoring, right? Something to keep in mind whenever we're factoring quadratic expressions, that sometimes there may not be a solution. And then one last thing, of course, we're learning how to factor quadratic expressions. That means expressions of degree of 2, right? But we could also, and this will come up later on in the future, we can also factor equations of higher degree. So that means we could factor equations that are, for example, such as you know, x cubed plus 3x squared plus 2x plus 1, right, for example. So just to keep that in mind, and as we look at the future chapters, I want us to keep this in mind, that when we're factoring, we're essentially using a process that allows us to find out the x-intercepts, essentially, right?